This lesson is on adding and subtracting radicals. When you add and subtract radicals, you're going to first look for like terms. And then once you identify the terms that are like, you're going to combine them either by adding or subtracting. And the way you do that is you're going to combine the coefficients. So that means you're going to add or subtract the coefficients. However, you are going to leave the radical exactly as it is. So the number inside that radicand, that's going to stay the same. And finally, just make sure that you simplify if you haven't done so already. So let's go ahead and look at some examples here of what like terms are. Right? We're trying to decide if these terms are like or not. If you look, both of these radicands are 3. That's what we're trying to look for. If the radicands match, then they are like. If you look at these, you say, oh, the radicands don't match, but be careful and make sure that you have simplified everything completely. For example, 2 is prime, but 18 is not, so you would want to figure out what the prime factorization is of 18 so we can simplify it. Well, 2 times 9 is 18, and then 3 times 3 is 9. So when we simplify the square root of 18, that's going to equal 2 times 3 times 3. Here's a twin. Remember, we get to pull it out, and you only get to keep one of them on the outside, and on the inside, that 2 is left. So what are we looking at? Well, really, we could say that that square root of 18 is the same as 3 square root of 2. Let's look at the radicands. That's all that matters. This radicand here is a 2. This radicand is a 2. These are actually like terms. Now, if you look at this next example, these are both prime. 5 and 2 are prime. And the radicands don't match. We would say that these are unlike. That means that these two could not be combined. These could be combined by adding or subtracting. These could be combined by adding or subtracting. But when they're unlike, they cannot be combined. So let's go ahead and look at some examples of how to add and subtract. Directions here are to simplify completely. Well, we notice here that our radicands are exactly the same, so we can go ahead and combine our coefficients. So it's like saying we have 6 minus 3. 6 minus 3 is 3, and we keep the radicand exactly as is. So you combine the coefficients, but you leave the radicand alone, or the radical alone. So now what we're going to do is we've got to make sure we've simplified this, and so I want to just double check. I'm going to do the prime factorization of 50. That would be 2 times 25. 2 is prime. And 25 is 5 times 5. There's a pair, so that tells me this is going to actually simplify. So the 3 comes on the outside to stay there like the coefficient, and then the 50 is comprised of 2 times 5 times 5. We're going to look for some twins. Here's a twin. It's going to come out, and what do we do with the outside number in that twin? Well, we're going to multiply them. So we keep just one of those 5s on the outside. On the inside, the 2 didn't have a pair. So 3 times 5 is 15, and we still have square root of 2. So this would be your final answer. If you look at number 2 here, these radicands don't match. However, we should double check and see if this simplifies any farther. So let's do the prime factorization of 20. That would be 4 times 5. And then 4 would be 2 times 2. There's my prime numbers. So this would be comprised of 2 times 2 times 5. And I look and I see a pair here. And since I'm looking for pairs of 2, I take out that. And remember, you only get to keep one, so it's 2 square root of 5. So this right here, the square root of 20, can be replaced with 2 square root of 5. Plus, we still have this 3 square root of 5. Now, if you look, these radicands in the inside do match. So my radicals match, so now I'm ready to add. Remember, we can add, these are like terms, so 2 plus 3, we add our coefficients would be 5, but you keep that radicand and you leave it alone. So the answer to this would be 5 square root of 5. On number 3, we got multiple things going on here. So let's go ahead and simplify each of these terms, and then we can see what can be combined. So I'm going to start with 5 square root of 125, and I want to do the prime factorization of 125. Since I see that that's divisible by 5, I could say we could divide that by 5. 5 times 25 is 125. This is prime. This goes to 5 and 5. So if I keep that coefficient 5 on the outside, and on the inside, we have 5 times 5 times 5. Here's a twin. We only get to take one out. So we already have the 5. We bring it down. One of these twins comes out, so we're done with that. inside is still a 5. So 5 times 5 on the outside is 25 square root of 5. Now this one, that square root of 5 is still just square root of 5. Here, we can look at negative 12 square root of 25. And I actually, if you know, 25 is a perfect square, so that's actually equal to 5. But if you didn't see that, then you can go ahead and still do prime factorization. So 25 is equal to 5 times 5. So we have negative 12, both of those are prime. So negative 12 square root of 5 times 5. So here's a pair of twins. We'll pull it out. And so when we pull it out, it's negative 12 times 5. And there's nothing left on the inside. That's it. So we can drop that radical symbol. And so now negative 12 times 5 is negative 60. Now we're ready to combine everything. This right here is equivalent to 25 square root of 5. Then we have this here, so plus square root of 5. And then we're going to take this term, which is minus 60. Well, these are like terms because they have the same radicand or radical. So this you got to be careful of. It's the most common mistake. If you don't see a number in front of here, there's an invisible 1. So it's like saying 25 plus 1, which is 26. Then we keep the radical 5. And this is not a like term with a whole number. This doesn't even have a radical. So my final answer is this right here. It's going to be an expression, essentially. All right, and then lastly, when we work with variables, it's the same concept. We want to go ahead and simplify each term. So we're going to go ahead and take the square root of x to the 7th, and we can go ahead and expand that. So we got 7 x's, 3, 4, 5, 6, 7. We're looking for twins. So here's a twin, here's a twin, here's a twin. So we got, how many are we pulling out? 1, 2, 3 x's that we're going to pull out. So that'd be x to the 3rd. Still inside would be an x. Well, this one here, if you look, it says minus x cubed square root of x. Well, there's one of these. It's not a twin, so that's already simplified. And if you look very carefully, these are exactly the same. So when it's the same thing subtracted by itself, we're left with 0. So that would be our answer on this question.